Well, hey there, kiddos. It's been a couple days since we had a video, so it's about time we jumped back in. So we are going to talk about graphing inequalities today. We've graphed lines. We've talked about how to use the slope and the y-intercept to graph a line, but now we're going to graph inequalities. And it's a little bit different because just like when we solved a regular inequality and you got something like this, x was greater than 4, and then we had to draw the number line and we had to do the open circle and draw the arrow to show all the values because x can be every number greater than 4. The same thing is true when you do a linear inequality. Your solutions or your solution set is going to be several numbers and not just one number. It's not going to be just the line, it's going to be parts of the graph. And so we're going to have to do some shading and we're going to have to talk about how to draw our lines. So first of all, there are some things we need to write down. I'm going to put a blank page in here. You can put this on the back of your notes because it should be blank on the back. So the first thing we need to do, we know our less than and our greater than symbols. So this is less and this is greater. And when we graph these two on our graph and we do them with a line, they will always be graphed using a dotted or a dashed line. So when you draw the line with a less than or greater than symbol, you have to draw a dotted line. You will not connect it and make it a solid line. It's just like having an open circle before. You will have an open line, so it's got to be dotted because your line will not count as a solution. If you happen to have the or equal to's, less or equal to, or greater than or equal to, then when we graph those, just like with when we would graph before, we would do a closed circle. When we graph these, they'll have a solid line. So if it's got the or equal to sign, then you have to draw a solid line when you graph it because the line can count as part of the solution. And we're going to talk about solution sets and where solutions are in just a second. But you do need to know these two things. It's good to have them written down. So if you look at this first problem, y is less than 4/3 x minus 4. I have a slope, which is 4/3, and I have a y-intercept, which is -4, and I'm going to use those to graph my line. And because this is just less than, it doesn't have the or equal to part, when I draw my line, it's going to be a dashed line or a dotted line, and because it doesn't have the or equal to part. And so we're going to graph this. We're going to start at -4, 1, 2, 3, 4, because that's our y-intercept. And then our slope is 4/3, which means I got to go up 4 and over 3. So I'm going to go up 4 and to the right 3. And I can do that again. I can go up 1, 2, 3, 4, and to the right 3 and get another one. And then I can connect those using a dotted line. And so it points on this line. If I were to plot a point that was exactly on that line, it would not count in my solution set because the line is dotted. So it means it doesn't count. Now I've got to talk about what does less than mean. Less than obviously means it's got to be less than whatever this line is, but when you have a line that is drawn diagonally, sometimes it's hard to tell what is less and what is greater. So here is how I do this. I have to shade the part of my graph that is going to be less than this line. And sometimes it's easy for people to see and sometimes it's not. So I'm going to show you how the easiest way I know of to remember this is. Go to your y-intercept and put your pen or your pencil there. Okay? If I want values less than my y-intercept, they have to be in this direction because numbers less than that will be that way. That means I have to shade in that direction. So I'm going to take my pen and I'm going to shade my part of the graph, the part of the graph that is in that direction. So this, it's hard to see my line now, is the solution to this linear inequality. It is this dotted line with this part that is shaded. And so any point inside this shaded region would be a solution and would be in my solution set. So there's a point. I could also have a point right here. I could have a point right here. Any point inside that shaded area would count as part of my solution set because all of these points, if I plug them into this inequality, would make it true. So let's graph another one. So I have y is greater than 5/2 x minus 4. So my slope for this is 5/2 or 5/2. My y-intercept again is -4. And this time it is just greater, which means I have to have a dotted line. So I'm going to graph using my slope and my y-intercept. So I'm going to start at -4. And this time my slope is 5/2, so I'm going to go rise 5 and to the right 2. So I'm going to go up 1, 2, 3, 4, 5 and over 2. And do it again, 1, 2, 3, 4, 5 and over 2. And just like with the last one, it's going to be a dotted line. So I can draw my dashed line through those points. And now I have to talk about which direction should I shade. So I know it is greater than because that's the symbol I have. So again, I go to my y-intercept and I put my pin there. And numbers greater than my y-intercept would be in this direction. So now I have to shade everything up here. So every point in this shaded region is now part of my solution set. And so if I'm asked for, give me a number that's part of the solution set, you pick a point, any point within that shaded region, because any point there will make this true. So let's do another one. So the next one, number 3, has a less than or equal to. So now it's underlined, which means when I graph, I'm going to get to do a solid line. But it is also not solved for y. You cannot graph this until y is by itself. So step 1, we're going to get y by itself. And I'm going to do that by adding x to both sides. This is a good review of solving for y. So I have -2y is less than or equal to x minus 8. And then in order to finish, I have to divide the whole thing by -2. So I have to divide all of this by -2. Since I'm dividing by a negative, this inequality symbol has to flip. So now instead of being less than or equal to, it's greater than or equal to. There's a 1 in front of that x, so it becomes 1 over -2x, which is the same as -1/2 x. And then -8 divided by -2 becomes +4. So there is my new equation. My slope, or my inequality, my slope for this is -1/2, and my y-intercept is 4. So we're going to start at 4. 1, 2, 3, 4. And now since my slope is -1/2, I'm going to go down 1 and over 2. So I'm going to go down 1 over 2. Down 1 over 2, and I can go backwards on this one too. I can go up 1 and to the left 2, up 1 and to the left 2. Would help if I actually went left 2 and not left 1. That last point's wrong. Up 1 and over 2. So there are some points that are going to be on my line, and because this is or equal to, it means that I get to connect my line. So I'm actually going to use a line this time because it's easier for me to draw a dashed one than it is to draw a dotted one. I mean a solid one. So I'm going to put my line on here. See, it lines up with my points. So there's my line. Now we have to talk about which way should we shade. You have to look at the answer you got when you solved for y, not what you started with. After you solve for y, the symbol was now greater than or equal to, so I have to shade the greater than part. So again, I go to my y-intercept. Numbers greater than my y-intercept would be up here, so I have to shade everything up here. So all of this part is going to be part of my solution set. And the cool thing about this is now since my line is solid, all of these points and any other point that is actually on that line is now included in my solution set. Up here they weren't. If I had taken this point and it's on the dotted line, this point right here doesn't count in this solution set, but this point does count because this one's solid. So now points on the line are part of the solution set. So if I were to ask you for a point, you could pick one on the line or one in the shaded region. They all work. So this next problem doesn't even have a y. But I can still graph it, but I need this x to be by itself. So the first thing I'm going to do is divide both sides by 4, so I have x all alone, and I'm dividing by a positive, so I can leave my symbol alone. So I end up with x is less than or equal to -1. Since it is just x equals, hopefully you remember, x equals is part of VUX, which means it has to be a vertical line. It's got an undefined slope. But since it is x equals, it means x will always equal -1. No matter where I am on my graph, where I am on the line, x will be -1. So x is -1 right here. And I could plot all kinds of points that's -1, but this has to be a vertical line because it's just x. So it's going to be a line that goes up and down through where x is -1. And because it's got the or equal to, it's going to be a solid line. So here is my vertical line. that is x is less than or equal to -1. So there's my x equals -1. That's the line. Now I've got to deal with this less than or equal to. And I can't do like I did on these because I don't have a y-intercept to start at, but I do have an x. I can pick a point. Any point on the graph will do. So I'm going to pick my x-intercept. And if I want to do less than, numbers less than my x-intercept are this direction. That means I need to shade everything on this side. And because my line is solid, any point in the shaded area or on my line now counts as part of my solution set. So let's try one more, and then you'll practice this when you come to class tomorrow. So number 5, I'm going to give you a second, pause, solve that for y, and then see if you can graph the line and shade it, and then come back and check your answer. So I have it solved for y here. I did all the algebra I needed. So I've got y is greater than or equal to 3/2 x plus 6. We're going to graph this, and hopefully you figured this out, but if not, follow along. So our y-intercept is at 6. 1, 2, 3, 4, 5, 6 right here. My slope is 3/2, which means I've got to go up 3 and over 2. But from here on my graph, if I count up 3, I'm off the graph. So I'm going to have to go backwards. So instead of up 3, right 2, I'm going to back it up. I'm going to go down 3, left 2. So I'm going to go down 1, 2, 3, and to the left 2. And I do the same thing, down 1, 2, 3, left 2. So now I have 3 points. I'd only need 2 to make a line. But this has a positive slope, and if I graph this, this will have a positive slope as well. And since it's or equal to, I get to have a solid line. So there is my line. And to shade it, it's greater than or equal to, well, from my y-intercept, that would be up this direction. So everything here is shaded. And so points in the shaded region and on this line, because it is solid, are part of the solution set. If it's a dotted line, the line doesn't count as the solution set. Pardon me. It's the shaded region only. So we will practice this tomorrow. If you have questions, make sure you're asking them, and I will see you then.